Hello everyone. My name is Shayan, and today I'm going to present our work, which is state machine-based human bot conversation model and services. Hope you will enjoy this presentation. All right, so let's first talk about conversation services and more specifically chatbots. As we all know, chatbots are kind of applications that they are programmed or designed to behave like a human. And the interaction between users and chatbots are basically with natural language expressions in the form of voice or text, and they are kind of programmed to perform an action or serve a service for the user. And more specifically, here we are talking about task-oriented chatbots. And there is another kind of chatbot which is a non-task oriented, but our focus in this work is a task-oriented one. There are examples, say Apple Siri, Google Assistant, and Amazon Alexa. I think we all are familiar with these conversational services. Before going to the details, I want to talk quickly about the terminologies in this context. The first one is the intent, which refers to the user intention, or what is the user purposes of asking a specific question or request. You see in the example here that show me some Italian restaurants near UNSW. The intention of the user by asking this question is that give me some suggestion or find some restaurants for me. The second terminology is utterance, or sometimes called expressions as well, or so means that whatever the user says, the input to the chatbot is considered as user utterance or user expression. And based on the user utterance, a chatbot can recognize what is the user intent. The third terminology is entity or slot. So these are the key information within user utterance. As you see here, that Italian restaurant is an important entity for the chatbot. Also, the UNSW, let's say it's a location or name of the restaurant. So these are the important informations for the chatbot in order to perform an action. The last terminology is dialogue act. These are the hidden actions. You can see it in the utterance. These are the hidden actions that they convey the meaning of the utterance. For example, it can be whether the user is making a statement, or the user is asking about question, or the user is negotiating on a suggestion, something like that. So for example, here you see that show me some Italian restaurants near UNSW. The dialogue act of the user is give me some suggestions. So this is called dialogue act, and it's very important in conversational or dialogue systems to understand what is the dialogue act of user utterance. Okay, so now I want to talk a bit about what is happening behind the scene. So whenever the user gives an utterance to the chatbot, it tries to map that utterance to an API call. Let's say whenever the user is asking about Indian eatery here in Randwick, the chatbot will use Yelp API to get the list of the restaurants and then show these results to the user. But the thing is, the interaction is not always as easy as it looks like. In fact, there are three different ways that users can talk with chatbots. Here, we are going to talk about these three, let's say, conversation patterns. The first one is single intent and single turn, meaning that chatbot and user, they're talking about one single specific intent during the whole conversation. Let's say they both talk about schedule a meeting. They don't talk about any other intents or topics. The assumption in this type of conversation is that the user provides all the information required to perform an action in one single utterance. Let's look at this example. Here, the user says, find a few restaurants near Opera House, meaning that the user provides the location in his utterance. And since the user provides all the required information, the chatbot will return the result very quickly and very simply. I mean, very easily. The second assumption is that the conversation is stateless. Every user utterance is treated separately, meaning that they are not related to the previous utterances. The limitation of this conversation type is that if user has some missing information in his utterance, the chatbot is not able to perform the required action, meaning that if user misses the location, the chatbot will not be able to show the list of the restaurants. The second type of conversation pattern is that single intent but multiple turn, meaning that the user and chatbot, they are talking about one specific intent. However, the user can provide the missing information gradually, meaning that if something is missing in the user utterance, let's say the user misses the location, the chatbot will ask the user to fulfill that or to provide that missing information. And then when the chatbot has all the required information, it will return the result. The last one, which is the most important one, is that multi-intent and multi-turn, meaning that the user and chatbot can talk about different intents or different topics in one single conversation. Sometimes they talk about schedule a meeting, then they talk about book a table in the restaurant, and so on and so forth. This type of conversation is really close to our day-to-day conversation, meaning that whenever you talk with your friends over the phone or you have a chit chat with your colleague, you're talking about different topics. You're not talking about one single topic. So, and again, the required information is scattered into multiple user utterances. And user can provide the missing information in the form of follow-up questions. And later you will see what does that mean. This type of conversation is really challenging for the chatbot to handle. And the reason is identifying when and why the user changes the intent, and also tracking the provided information by user for each intent is really challenging. So in order to handle this type of conversation, means that multi-turn and multi-intent conversation, in this paper we propose an approach which is a conversational state machine that leverages the concept of hierarchical state machine to represent the conversations as a sequence of states that each state covers or handles an intent. Basically, each state is a nested state machine. As you see here, this is a nested state machine that handles an intent, which is called search business. And this nested state machine is inside the whole state machine or a bigger state machine. And the transitions between the states are triggered based on the changes in user intent. In this state machine, we have two general types of states. The first one is the basic intent state. This state is basically when user utterance has all the required information, and the state machine goes to this state to perform the predefined action for that specific intent. The second one is the nested state, is when that user missed some information and the chatbot needs to fill this or to obtain this required information. In this case, the chatbot will ask the user to provide them required information or the missing information. Based on the user answer, The chatbot either will go to the nested slot value state, which means that the user explicitly provides the missing information, and the chatbot then will go back to the basic intent state to perform the action, or the user, instead of directly answer the question, the user will ask another question. Let's say when the chatbot asks about the location of the user, instead of saying that I am in University of New South Wales, the user will say that where is my university, right? In order to find out the answer, the chatbot first needs to perform an action or to perform another intent, and then get the result and then fulfill that missing information. Besides the states, we have transitions in this state machine. Uh, the first type of transition is when the user is asking about new intent. So basically, the state machine moves between one state to another. As you see in this example, when let's say the state machine was in search business state, when user asks about weather, it moves from search business state to get weather state to find out what is the weather condition. Second type of transition is a nested slot value, is when something is missing in user utterance, and the chatbot and the state machine will go to that nested slot value state. As you see here, the location is missing. So when it goes there, the chatbot will ask the follow-up question to fulfill that slot. The third one is when the chatbot asks user to fulfill the required information, and the answer from the user is basically another request. So as you see here that since the location is missing, the user will say, where is my hometown? In order to fulfill this location slot, the slot machine will go to another state, which is called get user details, and the output from this state is the value for this location slot. So based on the conversational state machine, we propose a conversational model that can be used as a conversation manager within chatbots to handle multi-intent and multi-turn conversations. This model has six main components. As you see in the figure, they have different responsibilities. In order to explore how our proposed conversational model effectively empowers chatbots to handle multi-intent, multi-turn conversations, we conducted a study. We asked participants to build DevOps chatbots using Amazon EC2 APIs. These chatbots supported 10 intents. We asked participants to use any of these four settings to build their chatbots. These settings were using with.ai chatbot platform or using with.ai platform plus our conversational model. The third one was using Dialogflow, which offers its own conversation manager. And the last one was using Dialogflow, but replacing the conversation manager with our conversational model. Then we evaluated the performance of chatbots considering these four metrics. The results were interesting. We saw a huge performance increase in performance for RQ3, where chatbots were using Dialogflow platform with our conversational model. Also, we saw an increase in performance in chatbots were using with.ai platform with our conversational model. In terms of future work, we plan to consider context besides conversation history, and also use co-reference resolution techniques. So that's the end of our presentation. Hope you enjoyed, and thank you for listening to our presentation.